Hi, welcome to this episode for class. Today we are going to be discussing work. No, we are not going to be discussing when you go to work or when you have to do schoolwork. We're going to be talking in the terms of physics. So, get ready to learn today. So, what you need to know by the end of this video, what you should know or have a basic understanding is what is work, what is the formula for work, what is the units for work, and how to solve for work. So, let's get started. So first we are going to start with what is work. Work is when a force acts on an object to make it move. So, when we take a look at this, work requires two things: a force and a displacement. Now, it might have been a while since you've heard these terms, so a force refers to a push or a pull. You push a box, you pull something forward, that is a force. Now, displacement means it has to move. So it has to have movement, it has to go somewhere. Forward, back, left, right, up, down. It has to move. So, we are going to take a look at these two examples and determine if work is occurring. So let's start by looking at this picture of this guy moving the box. So, first criteria is if there is a push or a pull force. So looking at this picture, is there a push or a pull force? Yes, the man is applying a pushing force on the box. He's pushing it, he's trying to move it. Now let's take a look at our second criteria. Is there a displacement or movement? Although he's pushing on it, I don't see movement. The box is staying put. So since the object, the box, is not moving, there is no displacement. So, we took a look at these two criteria, and we got to determine if there was work being done here. So, was work being done? Unfortunately, there was no work being done, because even though he was applying a push force, and even though he was applying a hard push force, since there was no displacement, no movement of the box, no work has been done on the box. So, we've taken a look at this picture of the man pushing the box, and we determined there is no work there. Let's go now and take a look at this guy pushing the button. So, let's take a look at our first criteria again. Is there a push or pull force? There is a push or pull force. The man is applying a push force on the button. He is pushing the button down, so he's applying a force. Now let's take a look at our second criteria of is there a displacement. Displacement, is it getting moved? Yes, the button is getting pushed down. It is moving down into the button socket. And since it's being moved down, it is being displaced. So, now we get to determine if work is being done here. Since there is a push force being applied, and there's displacement, there is work being done here. So, between these two pictures, the man pushing the box, even though he's trying hard, there is no work being done because there is no movement. However, the guy pushing down the button is doing work because he's applying a force and he is moving the button. So, now that we got this information, now that we got our definition down, we can look on getting ready to solve it. So, while we're getting ready to solve, we need to know our formula. So, in order to solve for work, you need to know the formula. The formula for work is you multiply the force applied to the object by the distance the object is displaced or moved. So, how this is written is W, which stands for work, equals the force applied times the distance the object moved. So, W equals F times D. That is our formula for work. Work equals the force applied times the distance it is moved. Now that we know our formula, we gotta get the second part before we can solve our equation. So, we need to know our units. The units for work combine the units for force and distance. Now, this means we gotta know both units. The units for force, as we learned back when we were learning Newton's second law, is newtons, which we write with the capital letter N. Now, when we were learning about distance at the beginning of the year, we learned that the usual unit is meters, with a lowercase m. Now, since we multiply these two, force times distance, in our equation, our unit for work is newtons times meters. Now, this is not the most common unit. The more commonly known unit is the joule, written with the capital J. Now, this is the one we will be using in this class. We will be using the joule. So, now that we know our formula, and now that we know our unit, we can now solve. So, we have our problem here. A forklift moves 34 meters, carrying a 1,023 Newton box across the warehouse floor. How much work is being done by the forklift? So, the first step always is to draw the box chart. You guys should know this chart by now. It's the FGWA box that we've done since the third day of school. So now that we got our box drawn, we got to write down our givens. W stands for work, F stands for force, D stands for distance. Now that we got our three variables down, we can now determine our givens by looking at the question. And the easiest way to do that is read through, and once we find a number, we stop and place it. So, we're going to start by reading. A forklift moves 34 meters. I am going to stop here because I see 34 meters. When I see the little m, I know we're talking about meters, and since meters is the unit for distance, I'm going to plug that in the D distance spot. So, now that we got that, we continue reading the question. So, a forklift moves 34 meters, carrying a 1,023 Newton box. Again, we see a number, so I'm going to stop. I see the letter N, and the capital letter N tells us that this is a force, so we're going to plug it in the F force spot. So, we can continue now. So that way we can find our last variable. So, a forklift moves 34 meters, carrying a 1,023 Newton box across the warehouse floor. How much work is being done by the forklift? Since we are solving for work, and it says how much work is being done, we place a question mark for our W. Now that we got this down, we can write down our formula. Our formula, as we learned a couple slides ago, is W, work, equals the force, F, times the distance, D. Now that we got our formula written, we can pull it up into our work box. So this way it will be easier when we substitute our information. So now we can substitute our information. W stays the same because we don't know what that is. Now we plug in our force, which is 1,023, I mean. I'll fix that later. Times 34 meters. Then we multiply and solve. That gives us 34,782 for our answer. Now that we got our answer, we can plug it into our answer box. So we pull that down, and work equals 34,782. Now, there's a problem here. We don't have our unit yet. And you know, we don't like naked numbers. So now, we have to attach our unit. As we discussed, the unit that we use is joules, so we put the letter J. So, at this point, we have learned how to solve for work. We have learned what work is, what is the formula for work, what are the units, and how to solve. So, now that we got this information, we are ready to learn more about work when you come to class. So, thank you, and have a nice day.